So we were doing graphs, right? Until yesterday, like the last thing we discussed yesterday was topological sort using modified BFS. That is Kahan's algorithm. I asked you people to try its code. Like, let me know if you were able to do it or what were the problems you were facing, or I should start with its code only, and after that we can move on to something else. Till now we have taken two classes: intro to graphs, adjacency matrix, adjacency list, edge list, implicit graphs. We have discussed BFS, DFS, topological sort along with their codes. So these topics have been covered. Right? Just quickly tell me whether you are able to do that code, or should we do it in today's class right now, or should I start with a new topic? जल्दी से बता दो who all are watching. Okay, so Ishan wants me to explain again. We'll quickly go through the algorithm and then we'll discuss a little bit of code. So what does topological sort means? It's basically how we resolve dependencies, right? Like yesterday we took an example. ऐसा हमने एक एग्जांपल लिया था. Example was something like you are given a graph. You start from the starting node 0. So the first thing that was applicable on topological sort was that the graph should be DAG. DAG stands for directed acyclic graph. So I hope you people are clear with what is directed acyclic graph, right? So directed acyclic graph is a graph that should be directed and it should not have any cycle in between it. So now from this graph what we can conclude is we have two nodes with which are not dependent upon anything. So this is the node and this is the node. So their in degree is 0, it's in degree 0. Now two nodes are pointing towards this, so its in degree is 2. One node is pointing towards this, so its in degree is 1. Two nodes are again pointing to this, so its in degree is 2. One node is pointing to this, so its in degree is 1. So we calculate the in degrees for each node. So the first thing is we calculate the in degrees for each node. After we have calculated the in degrees for each node, we create a queue. Like as I said, it's a modified BFS. So we create a queue and we push in 0 and 1. Why only 0 and 1? Because they have 0 in degree. Now when I remove 0 from this queue and I print it in this traversal, so once I remove this 0, this dependency will be reduced, this dependency will be reduced, so its in degree will also be reduced. It will be 2 minus 1 is equal to 1, and it will be 1 minus 1 is equal to 0. So now the in degree of 4 is 0. Now as soon as the in degree of any element becomes 0, so we add that element in our queue. So now 4 should be added to our queue. I have added 4. Now we are on 0. Now I'll remove 0 from here. I'll mark 0 in the output. This should be the output, right? And now 0 is removed, so this dependency is removed. Now it should become 0. Now in degree of 2 is 0, I'll add 2 in my list. I'll remove 4, I'll print 4, I'll remove this dependency, in degree becomes 1, and now I have 2, I'll remove 2. Once I remove 2, so this dependency is reduced. I'll print 2 here, 1 minus 1 is equal to 0. So 3 is here. Now again 3 will be added to this. As soon as 3 is added to this, now I remove 3. 3 is deleted from here, will print 3 here, and now 5 will delete 5, in degree becomes 0, will print 5. So this is basically the topological sort of given graph, right? So let me just code it briefly so that we can discuss how the code works. इसका एक बार कोड लिख लेते हैं बड़ी जल्दी जल्दी में, फिर उसके बाद हम आज के टॉपिक्स पे आएंगे, राइट? तो इसका कोड क्या होगा? लेट्स से वी क्रिएट अ फंक्शन टोपोलॉजिकल सॉर्ट, void topological sort. So the first thing that we did in topological sort was we have to calculate the in degree, right? So I create a vector int in degree with v and 0, right? Initially all the in degrees are 0. Next I'll iterate over all the edges to find out the right in degree. To iterate over all the edges, what I'll do, for int I is equal to 0, I less than v, and I plus plus, I'll do for auto neighbor in the list of this particular I. So I'll go on to all the neighbors and in degree will be increased by 1. Now this is done, right? After this I'll again write the code for BFS as we did. So code for BFS was, the first thing that we need to do is we need to create a queue int queue. Then I'll initialize the queue with nodes having 0 in degree. So to initialize the queue with nodes having 0 degree, what I'll do, I'll run a for loop. For int I is equal to 0, I less than v, I plus plus, if in degree of I equal to 0, then I'll push this in my queue, right? Now I'll try to run this loop and try to start popping from the queue and printing it in the output. So I'll start popping from here, right? Now while the queue is not empty, int node is equal to queue का front, right? And I'll do cout node and I'll simply do queue का pop. हमने फर्स्ट वाली नोड को प्रिंट करवाया, फिर उसको पॉप कर दिया. नाउ व्हाट आई विल डू, I'll iterate over all the neighbors of this node and reduce their in degrees by 1. मतलब इसके सारे neighbors की in degree एक एक कम हो गई, right? I'll do for auto neighbor L of node in degree of neighbor minus minus, and if in degree of neighbor becomes equal to 0, I'll do q का push neighbor. As soon as the in degree of any of the nodes becomes 0, I'll again push it into the queue and I am done with the code. This is basically the code for our topological sort. Let me just dry run it once. Let me just bring this there. So here what you can see, this is the topological sort function. Firstly, we have created this vector in degree that is initialized with 0 because all the nodes are 0 initially. Then we create a for loop. We'll go to each and every vertex of this graph, and for every neighbor of this vertex I'll increase the in degree by 1. So in degree of neighbor plus plus. Then I'll run the BFS वाला code. BFS वाले code में सबसे पहले हम क्यू बनाएंगे. क्यू बना के हम जिस जिस भी ग्राफ की नोड की डिग्री इन डिग्री 0 इनिशियली, तो हम उसको ग्राफ में पुश कर क्यू में पुश कर देंगे. उसके बाद हम पॉप करना स्टार्ट करेंगे. हम ग्राफ से एक एक करके सॉरी क्यू से एक एक करके नोड पॉप करते जाएंगे एंड उसको प्रिंट करते जाएंगे. उसके बाद आई चेक ऑन कि जो मैंने नोड डिलीट कर दिया है उसकी इन डिग्री 1 से कम हो गई है, एंड एट एनी पॉइंट इफ द इन डिग्री ऑफ नेबर बिकम 0, तो आई पुश दैट इन द क्यू एंड इन दिस वे इट गोज. आई होप इट इज क्लियर. एक बार खुद से कोड रन करके देखना एंड यू विल फाइंड द एग्जैक्ट प्रॉब्लम. तो लेट्स मूव ऑन टू टुडेज क्लास. तो आज की क्लास में वी आर गोइंग टू डिस्कस साइकिल डिटेक्शन इन अनडायरेक्टेड ग्राफ. सो द फर्स्ट प्रॉब्लम दैट आई हैव ब्रॉट टू यू इज cycle detection in undirected graph. So what do you mean by a cycle? Like let's say I have a particular graph 2 4 3 1 0 9. So this is a kind of graph. Do you see any cycle here? No, there is no particular cycle. So this can be considered as a tree also. Isn't it a tree? So basically if somebody asks you what is the difference between a graph and a tree, graph not containing any cycle is a tree. Right? The graph which is not having any cycle, it is known as a tree. And similarly, let's say you have this particular example in which there are some other nodes like 1 3. So in this graph you have this particular cycle. Like you start from 4, you go to 8, you go to 0, you come again to 4. So this cycle is there in this undirected graph. Hi Shan, that question only I am taking right now. how to check that whether it's like whether there is a cycle or not in a graph. So you can do it right here, but like let's believe that in that question we were already given a directed acyclic graph. तो मैंने इसलिए वहां पे नहीं किया. अब ये वाला साइकिल डिटेक्शन वाला कोड तुम कर लोगे तो उसके बाद आई बिलीव तुम्हें वो चीज भी क्लियर हो जाएगी, राइट? इसको हम एक सेपरेट क्वेश्चन की तरह कर रहे हैं. तो अब इसमें ये साइकिल बन रहा है यहाँ पे. तो व्हाट विल डू इज विल ट्राई टू यूज आर डीएफएस अप्रोच. हमने कल डीएफएस पढ़ी थी. So what we'll do, we'll start from this node, maybe let's say we'll start from node 4, then we'll go to let's say node 1, we'll go to after 1 we'll go to see its neighbor is 3, we'll go to 3, we'll move to 3, we'll see there is a its neighbor 2. So and we come like after 2 we'll have to come back to 3, then again to 1, and then again to 4. Now I come back to 4, then I'll move to let's say 0. Once I move to 0, then I'll see the neighbors of 0. I have this 8. Once I go to 8, then I'll see its neighbors. I have two neighbors of this 8. So 8 has two neighbors. One is 4 and one is 0. So when I carefully look at the neighbors of 8, what I see is 0 is also the neighbor of 8 and 4 is also the neighbor of 8. But 4 is already visited and 0 is also already visited. But what is the difference in both of them? Like 0 is the parent of this 8 and 4 is not the parent of this 8. So now we'll categorize them on the basis of whether a particular node is a parent of another node or not. So hence this condition comes into picture. Neighbor is not equal to the parent of node. So once I get to this particular point where neighbor is not equal to the parent of node, I'll have to make this check also, right? Once I see that 8 4 is the neighbor of 8 but it is not the parent of 8, then it is automatic that this particular graph contains a cycle. So this is the basic code for how to check a cycle in an undirected graph. Let me know if you people have any doubts in this, or should I explain it again? All those who are listening right now, should we move ahead with the code part of this undirected graph, or should I explain it once again? Let me just take it up once more so that it becomes even more clear, right? So to check a cycle, in an undirected graph, let's say you have two graphs, one is 4 3 2 1 6 and 7, and another is 2 sorry 1 0 4 8 and this. So you have two graphs. This graph is a graph that does not contain a cycle, whereas this particular graph contains a cycle and it lies here, right? So now how I'll check upon this cycle, what will you will use the DFS technique. DFS stands for depth first search. So we'll start from this particular node. I'll start from 4, I'll go to let's say 2. Once I go to 2, I'll check for the neighbors of 2. 1 is the neighbor of 2, I'll go to 1 and I'll call again. I'll again go to 0 and I'll again call DFS. Once I move back from 0, I come back to 1. I again move back to 2. Again move back to 4. Now I have 2 more choices. I'll go to 6. Again call DFS. I'll go to 8. Now once I go to 8, I see there are two neighbors of 8. One is 6 and one is 4. Out of 6 and 4, both 6 and 4 are parents of 8. Sorry, both 6 and 4 are neighbors of 8. Whereas 6 is the parent and 4 is not. So once you get this condition that neighbor is not equal to the parent, that means you are returning to some point that we have already visited, and that is also not the parent. So this condition tells us that there is a cycle in the graph. Right? I hope this much is clear. Should we move to the code part? Just quickly tell me. इसे कोड पे चले. Hi Shan, Yash, Fanny, few people are there. Can you please? वो कोड में लिखेंगे ना यार. How will calculate whether it's a parent or not? That we'll see in the code. Will automatically मतलब हम DFS में मॉडिफिकेशन कर देंगे. हम parent भी पास करेंगे हर नोड का साथ में when we are running the DFS function, right? ठीक है जी. So now we are discussing the code for undirected graph में cycle ढूंढने वाला code. So like as you people, as we have already seen, for this particular kind of question I'm using an undirected graph. So for undirected graph, I'll quickly create an add edge function. When I run this add edge function, int x, int y, right, L of x में I'll push back y and L of y में I'll push back x. So this is the add edge function basic for undirected graph. Now I'll create a new function, let's say bool contains cycle, because this is something that we are going to check. And bool contains cycle में what we'll do, सबसे पहले what we'll do, we'll create a vector of bool visited that will contain our visited arrays. I'll initially mark all of them as false. Then I'll call upon this DFS function. So DFS में what I'll pass upon 0, that is the source node. Then I'll pass upon visited array, and then I'll need to pass upon a parent node. तो 0 के लिए कोई parent node नहीं है, तो 0 के लिए I'll pass on -1. अब हम DFS लिखते हैं. When I have written bool DFS, so int node vector bool of visited and int parent. These three things I have passed on. Now I have to mark the nodes as visited. सबसे पहली चीज व्हाट आई डू, विजिटेड ऑफ node is equal to true, right? Then I'll check upon for auto neighbor of all of them. If the neighbor is not visited, अगर तो वो neighbor नहीं visited है, then what I'll do, I'll check whether it contains a cycle. तो उसके लिए मैं फिर से एक recursive call लगा दूंगा. Recursive call will be nbr found a cycle is equal to dfs. अब इस dfs में what I'll pass the neighbor, I'll pass the visited array, and I'll pass the node, because here node becomes the parent. हम node के children की बात कर रहे हैं ना. Right? So if nbr found a cycle is true, then we'll return true. Else what we'll do, we'll return यहां पे हम चेक करेंगे else if nbr is not equal to parent, तो I'll return true. तो यही हमने कंडीशंस लिखी थी टोटल. आई होप, मतलब मुझे लगता है कि तुम्हें थोड़ा सा समझ में नहीं आया होगा. लेट मी जस्ट रिपीट इट अगेन. So this is the code basically that we are going to see. तो इसमें सबसे पहले हमने क्या किया, हमारे पास एक add edge function था. Let me just take that. Right. So this is the code that we have written. So in this code, what you will see is, सबसे पहले we have created this function known as bool contain cycle. So in this bool contain cycle, I have created a visited array that will take a note of like which all nodes are visited or not. Then I'll simply run a DFS call in which I'll pass on 3 parameters. Out of these 3 parameters, the first parameter is the node that we are going to do, going to work upon. Second is the source node. Next is the visited array, and third is the parent. So parent of source node is -1. So we'll pass upon this DFS. It will go here and DFS function will run. So when the DFS function is running, so the first thing is we come and mark this visited as true because we have visited that particular node. This is the source node. Then we go to each of the neighbors of this node and check and make a DFS call on the neighbors, right? जैसे ऐसे था ना. तो I passed upon this. इसका parent is -1. It will come to the visited node. Visited में इसकी वैल्यू ट्रू हो जाएगी. It will go to its neighbors, मतलब इसके neighbors विजिट करेंगे. अगर उसका neighbor नहीं visited है तो 2 is not visited. I'll again call this DFS on this particular value. तो अब NBR की जगह पे 2 पास हो जाएगा visited and node की जगह पे 3 पास हो जाएगा. It will again run the code. 2 के बाद जाके 1 पास होगा तो यहाँ पे 1 पास हो जाएगा, यहाँ पे 2 चला जाएगा, फिर it will be 4 and then it will be -1 again. तो इस तरीके से this cycle repeats and at any point of time if this returns a true, मतलब इसने हमें रिटर्न किया ट्रू कि साइकिल एग्जिस्ट कर रहा है, तो विल सिंपली रिटर्न ट्रू. एल्स इफ हम चेक करेंगे कि नेबर इज नॉट इक्वल टू पेरेंट. तो इस केस में क्या हो रहा था, हमने यहाँ पे चेक किया था ना कि हम यहाँ पे आए, we checked this is the neighbor of this is the neighbor of this, but this is also the neighbor of this but not the parent of this. Whenever it is not a parent of this, so that means कि हमारा इसमें loop exist कर रहा है. Our graph contains a cycle. Our undirected graph contains a साइकिल। अगर ये कोई भी कंडीशन ट्रू नहीं हुई देन विल सिंपली रिटर्न फॉल्स, राइट। जस्ट क्विकली हैव अ गो थ्रू, मतलब 2-3 मिनट दे रहा हूँ, इसको अच्छे से देखो फिर हम डिस्कस करते हैं इसका, राइट। अगर कोई प्रॉब्लम हुई तो हम डिस्कस करते हैं। जस्ट क्विकली से यस और नो इफ यू पीपल कैन, इफ यू पीपल हैव अंडरस्टूड। अगर नहीं समझ में आया तो भी बता दो, आई विल रिपीट इट अगेन। Should we go ahead? चलो, the next question that we are going to discuss today is Dijkstra's algorithm. So it is a single source shortest path algorithm. Single source shortest path algorithm. मतलब इसमें काफी सारी एल्गोरिथम्स आती हैं, मतलब व्हेन आई से सिंगल सोर्स शॉर्टेस्ट पाथ, तो इट इंक्लूड्स Dijkstra's algorithm also. It includes Bellman-Ford algorithm also. When it comes to all pairs shortest path, then comes Floyd abortion. तो हम आज की क्लास में ये डिस्कस करने वाले हैं। तो व्हेन आई से सिंगल सोर्स शॉर्टेस्ट पाथ, इसका क्या मतलब है? सिंगल सोर्स शॉर्टेस्ट पाथ का मतलब है कि लेट्स से आई हैव दिस पर्टिकुलर ग्राफ ए बी सी एंड डी। So let's say this is the source, right? तो इस D से हमने सारी नोड्स का डिस्टेंस कैलकुलेट करना है, एंड व्हाट इज द शॉर्टेस्ट डिस्टेंस। अब व्हाट इज द शॉर्टेस्ट डिस्टेंस टू B? तो B के लिए ये शॉर्टेस्ट डिस्टेंस होगा, C के लिए ये शॉर्टेस्ट डिस्टेंस होगा, D के लिए ये शॉर्टेस्ट डिस्टेंस होगा। D के लिए देयर इज अनदर पाथ आल्सो, यहां से यहां भी जा सकते हैं, यहां से यहां भी जा सकते हैं, यहां से यहां भी जा सकते हैं, बट नो दिस इज नॉट द केस। हम C के लिए यहां से यहां भी जा सकते हैं, बट दिस इज आल्सो नॉट द केस। हम डायरेक्टली ऐसे मूव करेंगे, एंड दिस इज नोन एज, this is what we actually do in single source shortest path. तो now we are going to discuss Dijkstra's algorithm. तो Dijkstra's algorithm तुमने सुना होगा पहले कभी। तो what actually is there in Dijkstra's algorithm? thing is it is applicable only to weighted graphs. जहां पे भी तुम्हें weighted graphs दिखें तो वहां पे Dijkstra algorithm लगेगी, and it is single source shortest path algorithm. Right, so these are the two things that we should see while checking for Dijkstra's algorithm. उसके अलावा what else is there in Dijkstra's algorithm? So Dijkstra's algorithm is something like, let's say you have this particular graph 0, 1, we have 2, we have 3, we have 4. तो कुछ ऐसा ग्राफ है तुम्हारे पास. It starts from this is the starting nodes or the source node. This is infinite, this is infinite, this is infinite, this is infinite. Initially all the distances are infinite. Distance from the source node to all the nodes are infinite initially. Right? So what I'll do in this case is I'll create a distance array. So in this distance array, I'll mark the distances of all the nodes. Initially the distance of 0th node, first node, second node, third node, fourth node, fifth node. 0th node is 0. Rest all the nodes are at distance infinity. Right? So we go from 0 to 1. When I go from 0 to 1, from 1 we see which all nodes we can visit. Right? Also, there are two data structures I'll create. This is the distance array, and I'll also create a set. So what will be there in this set? This set will be having two things. Firstly, the node on which we are visiting, like 0, 1, and it will be having the distance. So initially I'll add 0 and 0 because this is the distance that we have, and set, there's a property of set that it sorts the elements according to ascending order. So शॉर्टेस्ट डिस्टेंस हमारे पास सबसे पहला एलिमेंट होगा सेट का. राइट? So this is the set and this is the distance array. Now from 0 I go on to 1 and I'll see, like, let's say its weight is 1, its weight is 1, there is one more weight connecting them, it's 4, there's another weight connecting them, it's 2, another weight connecting them, it's 7, another weight connecting them, it's 3. So when I go from 0 to 1, so the weight that is there is 1. So as this 1 is less than the already present distance is infinity, so I'll cut this infinity and I'll mark it as 1. Here also I'll cut this infinity and I'll mark it as 1, and I'll add this 1 and 1 here, right, into this set. Now I can remove this 0 and 0 because we have already visited. Now I go to 1 and I'll check for the neighbors of 1. When I check for the, now what it means is 1 is finalized. 1 से 1 के लिए there is no other thing, there is no other distance that can be lesser than this. So what I'll have to do is I'll check upon for its neighbors. When I check upon for its neighbors, so 1 का neighbor क्या है 2 and 1 का neighbor, अगर 1 का neighbor 2 है तो what is the distance it is getting? यहाँ से 1 आ रहा है, यहाँ से 1 आ रहा है, तो ये infinity 1 plus 1 हो जाएगा. So it will be 2. Earlier it was infinity, तो यहाँ पे हम infinity की जगह पे 2 लिख देंगे and I'll add this node to my distance array. So it will be 2 comma, नहीं sorry, there is a little bit of problem. हम जीरो से वन पे नहीं जाएंगे, हम जीरो की सारी नोड्स को पहले देखेंगे, जीरो से टू पे जाने के तरीके, जीरो से वन पे जाने के तरीके, एंड जीरो से थ्री पे जाने के तरीके। जीरो से वन पे जाने के लिए देयर इज वन डिस्टेंस, तो आई मार्क दिस इन्फिनिटी एज वन। फिर हमने जीरो से टू में जाने के लिए एक तरीका देखा, देयर इज अ डिस्टेंस ऑफ फोर। मैं इन्फिनिटी को काट के यहाँ पे फोर लिख दूंगा एंड इट विल बी ऑल्सो फोर। और हम इसमें सेट में ऐड कर देंगे 2 comma 4, 2 is the node and 4 is the distance. Also from 0 I can go to this 3, the distance is 7, I'll cut this infinity as 7 is less than infinity and I'll add this in my set. Now for this, the node that comes in the front is 1, so I'll mark this as finalized. So 1 is finalized, then I go to 1. From 1 I have only one option, that is for this particular 2. So when I go to this particular 2, there is a distance of 1, so this is already 1, 1 plus 1 becomes equal to 2. So this 2 is less than already present value 4, so it will be 2 here. So what I need to do is I need to remove this from the graph and add a new entry of 2 comma 2, right? After this, what I'll see, now I come to this 2, from 2 I have this option, I can go to 3, so the distance at 2 is 2, 2 plus 2 becomes equal to 4, now I'll compare this 4 and 7, so 4 is less than 7, so I'll cut this 7 and I'll add 4, so it will be like, I'll delete this thing and I'll add 4 comma 3, right? In this way, we'll move on to all the nodes. From 3, I have an option to go to 4. So till 3, there was the total distance was 4. Now 4 plus 3 becomes equal to 7. Now I'll cut this infinity and mark it equal to 7. So this is basically the algorithm that will help us to calculate the shortest distance, so that from 0 to 4, the shortest distance is 7. This will come as our final answer, right? Just let me know if this is clear or you want me to repeat it once. All those who are watching the chat, watching the live, please go and like the stream. So we'll not go to the actual code for Dijkstra's algorithm today, as due to some time limitations. But probably we'll try to wrap it up in tomorrow's class, and I'll cover two more algorithms. We'll probably start with minimum spanning tree. It has different algorithms like prim, Kruskal. So we'll try to discuss the theory part and code part of these two. Along with that, I'll see what else we can do in graphs. But till now, I hope like today's class was a little heavy for you, because we have moved upon to algorithms directly from BFS DFS. But this is something that you people need to understand it well, if not first time, but when you revisit it for 2 times, 3 times, then definitely you will be able to understand the things behind today's class, right? I'll close the session for today. Let's meet in tomorrow's class.